Now let's move to Ogive curves or cumulative frequency curves. Sometimes we are interested in the number of observations below a particular value or above a particular value. In other words, we need all the accumulated observations. For example, we need to find population below poverty line. We would like to know the marks of top 5% students in a class. Such questions can be answered using less than type cumulative frequency distribution or more than type cumulative frequency distribution. Naturally, we would like to represent it by graph. The corresponding graphs are called as less than type cumulative frequency curve and more than type cumulative frequency curve. The curves are also called as Ogives or Ogive curves, cumulative frequency distribution, or more than type cumulative frequency distribution. Now let's look at the procedure for drawing Ogive curves. First, draw x-axis and y-axis. Then choose appropriate scales. Then make the classes continuous if they are not so. Then prepare less than type cumulative frequency table with the following columns. Upper boundary of class U1, less than cumulative frequency F1. Then take U1 on x-axis and F1 on y-axis. Then plot the points U1, F1. Take additional points as lower boundary of the first class with F1 is equal to 0. Then join the successive points by smooth freehand curve. We get less than cumulative frequency curve. Then make the classes continuous if they are not so. Then prepare more than type cumulative frequency table with the following columns. Lower boundary of class L1, more than cumulative frequency F1. Then take L1 on x-axis and F1 on y-axis. Then plot the points L1, F1. Take additional point as lower boundary of the first class with F1 is equal to 0. Then join the successive points by smooth freehand curve. We get more than cumulative frequency curve. Friends, note that median can be obtained from Ogive curves. How to interpret such cumulative frequencies? Number 1. Less than cumulative frequency gives the number of observations less than the upper boundary of the class. Number 2. Less than cumulative frequency is associated with the upper boundary of the class. Number 3. More than cumulative frequency is associated with the lower boundary of the class. It indicates number of observations more than the lower boundary. Let's look at an illustrative example which explains how to draw an Ogive curve. Example: life of battery in days was recorded in the given frequency distribution. Draw less than type cumulative frequency curve. Hence, find the median life of battery. Solution. Let's start with the procedure. First, we add up the class frequencies from top to bottom. To draw less than type cumulative frequency curve, we prepare the table mentioning the upper boundary of the class intervals and less than cumulative frequency. Now let's take upper class boundaries on x-axis and less than cumulative frequencies on y-axis. We take an additional point preceding the first class interval with corresponding frequency 0. Thus, we plot the points 50, 0, 100, 20, 150, 62, 200, 155, 250, 207, 300, 220. We join these joints by smooth freehand curve. Thus, we get the desired less than type cumulative frequency curve showing the life of batteries. We have to find the median life of battery. Median is the middlemost item in the ordered arrangement of data. Therefore, it is the value of n upon 2th item, where n is the total frequency. Here, y-axis gives the serial number of the item and x-axis gives its numerical value. We match the serial number and its value with the help of less than cumulative frequency curve. Accordingly, we mark the middlemost observation n upon 2, that is 110 on y-axis. In the above graph, it is at A. Draw a line segment AB parallel to x-axis. The line segment cuts the less than cumulative frequency curve at B. The point B has x-coordinate median and y-coordinate n upon 2. We draw a line segment BC perpendicular to x-axis. The foot of the perpendicular is the median. Here, the median is 175. Now let's note down the nature of less than type cumulative frequency curve. Number 1. The curve is like the English alphabet S, slightly elongated or stretched. Number 2. The curve is increasing. Number 3. It starts from x-axis. Number 4. It goes up to n, the total frequency. Number 5. The curve starts from x-axis at the lower boundary of the first class. So, if the lower boundary of the first class is other than 0, the curve does not start from origin. Let's solve one more example. Time spent in queue by 100 passengers is classified and given. Draw both the Ogive curves on the same graph paper. Also find median graphically. Solution. Let's prepare a table as shown. First, we will make the classes continuous and write frequencies, upper class boundaries and lower class boundaries. We find less than type cumulative frequencies by adding class frequencies from top to bottom and place it against the upper class boundary. We take an additional point, lower boundary of the first class 0. Here it is 19.5, 0, frequency 0. We plot the points U1, F1 and join the successive points by smooth freehand curve. We get less than type frequency curve. Now we find the more than type cumulative frequency by adding class frequencies from bottom to top and place it against lower boundary of the class. We take an additional point, upper boundary of the last class 0. Here it is 69.5, 0. We plot the points L1, F1 and join the successive points by smooth freehand curve. We get more than type frequency curve. Now we will draw a median. Draw a perpendicular AB to x-axis from the point of intersection of the ogives. The foot of the perpendicular is the median. Here it is 47 approximately. How to interpret this graph? Median is 47 minutes, means half of the passengers have to spend at least 47 minutes in queue. The remaining half may be in queue for at the most 47 minutes. Let's solve sums from exercise 6.4. Number 1. The following table shows the frequency distribution of salary of employees per month. Draw less than type cumulative frequency curve, hence find the median. 12 employees have salary below rupees 5,000. 27 employees have salary between rupees 5,000 and 10,000. 52 employees have salary between rupees 10,000 and 15,000. 18 employees have salary between rupees 15,000 and 20,000. 3 employees have salary between rupees 20,000 and 25,000. Solution. Prepare cumulative frequency table as shown with following columns. Class, frequency, upper boundary taken as U1, less than cumulative frequency F1. Draw x-axis and y-axis. Take scale of 1 centimeter equal to 5,000 rupees on x-axis and 1 centimeter equal to 20 employees on y-axis. Take U1 on x-axis and F1 on y-axis. Plot the points U1, F1. Take an additional point as lower boundary of the first class with frequency 0. Join the successive points by smooth curve. This is the less than frequency curve. Mark the middlemost observation n upon 2 on y-axis. Take this point as P. Draw a line segment PQ parallel to x-axis. Let this line cut the frequency curve at Q. Draw a line perpendicular to x-axis from Q. The foot of the perpendicular R is the median. Here, the median is 12,788.46, which is approximately 12,789. Number 2. Draw more than type cumulative frequency curve for the following data on time required to do a certain job. To do a certain job, 100 workmen require about 50 hours. 98 workmen require about 70 hours. 90 workmen require about 90 hours. 60 workmen require about 110 hours. 35 workmen require about 130 hours. 21 workmen require about 150 hours and 2 workmen require about 170 hours. Solution. Prepare cumulative frequency table as shown with following columns. Class, frequency, lower boundary taken as L1, more than cumulative frequency F1. Draw x-axis and y-axis. Take scale of 1 centimeter equal to 20 hours on x-axis and 1 centimeter equal to 50 workmen on y-axis. Take L1 on x-axis and F1 on y-axis. Plot the points L1, F1. Take an additional point as upper boundary of the succeeding class with F1, 0. Join the successive points by smooth curve. This is the more than frequency curve. Mark the middlemost observation n upon 2, that is 203 on y-axis. Take this point as M. Draw a line segment MR parallel to x-axis. Let this line cut the frequency curve at R. Draw a line perpendicular to x-axis from R. The foot of the perpendicular S is the median. Here, the median is 91. Number 3. Draw both the Ogive curves on the same graph paper for the following frequency distribution. Also, find the median. IQ of 2 students is between 60 and 79. IQ of 9 students is between 80 to 99. IQ of 15 students is between 100 and 119. IQ of 11 students is between 120 and 139. IQ of 3 students is between 140 and 159. Total number of students is 40. Solution. Prepare cumulative frequency table as shown with following columns: class, frequency F1, upper class boundary U1, less than cumulative frequency F1, lower boundary taken as L1, more than cumulative frequency F-1. Draw x-axis and y-axis. Take scale of 1 centimeter equal to 20 units on x-axis and 1 centimeter equal to 5 students on y-axis. Take extended classes on x-axis and cumulative frequency on y-axis. Plot the points F1 and F-1. Join the F1 points by smooth curve. This is the less than frequency curve. Take an additional point as upper boundary of the succeeding class with frequency 0. Join the successive points of F-1 by smooth curve. This is the more than frequency curve. Draw a perpendicular PQ to x-axis from the point of intersection of the ogives. The foot of the perpendicular is the median. Here it is 111.5.